Craig Double, and I'm going to show you Lab 7 chemical bonding. This is the Lab 7 that's in the Chemistry 1 with lab class. Lab 7 actually has an exercise 1 that you do, and then an experiment after that, experiment 1. So there's 2 parts to this. Prior to that, you do a pre-lab questions. There's 2 of them. One says draw an electron dot diagram of methane. You can get a lot of help from this from the book. If you still don't figure it out from the book, there's some good stuff online, and I highly recommend looking at the Khan Academy videos, and I'm going to probably put some links down at the bottom of this video so that you have that available. But bottom line is it's pretty easy once you actually get the hang of it and kind of study your periodic table, and that's what you're going to really need to use to help you figure this all out for this exercise. So exercise 1, it's an experiment where we're going to create models to explore the formation of covalent and ionic bonds. So, question number 1, what's a covalent bond? What's an ionic bond? What's the difference? So you kind of have to understand that before you get started. But from what I understand and looking at the book and stuff, on your periodic table, if you look at a periodic table, there's on the left-hand side where you have lithium, sodium, potassium, rubidium. Okay, that's in your group 1. And we're only really dealing with the major groups in this exercise, so you don't have to really worry about the metals in between. But the alkali metals and alkaline earth metals they typically have, group 1 has 1 electron or valence electron, so 1 electron is most outer shell. And then for group 2 or the alkaline earth metals, they have 2. So if you just go across the periodic table, you can kind of figure out the valence electrons or the number that are supposed to be there, depending on the group they're in. So one of the things to remember is that all these over here, these 2 guys, especially the alkali metals, that group 1, they tend to want to give away their electron in their outermost shell, their valence electron. Whereas over here on this side, where you have let's say group 7, maybe group 6, okay, so your non-metals and your halogens, the halogens like to take electrons, or the outermost shell electrons. So that's why a common one you see is sodium chloride when you put together. Well, sodium likes to bond with chlorine to make salt, because the sodium is willing to give its electron up to the chlorine takes it, and that's why sodium has kind of a positive charge and chlorine has a negative charge. So why is that really happening? So the way I understand it, the way I get it, is that everybody's trying to combine one side to the other because they all envy or want to be like the noble gases. And if you watch some of the videos in the Khan Academy videos, they'll explain a lot of this to you so you understand it. That's kind of how they go through it when you're doing the bonds. So before I get any further, that's kind of how you kind of have to understand the difference between an ionic and a covalent bond. Covalent bond, the electrons are just sharing. So an easy way to kind of think about that is if you take 2 oxygen atoms, and 2 oxygen atoms they're the same atom, so you're not looking at negative and positive really. You're just looking at 2 oxygen atoms trying to put them together to get oxygen, O2, and they'll form a covalent bond. And in a covalent bond, you're actually they're just sharing the electrons, and it's pretty much that simple. All right, chemistry is definitely not simple, but that's the best way I can explain it. So for this exercise, what you're going to need is 14 pieces of 3 by 5 inch rectangular corkboard. You're going to need your colored push pins. So in my lab kit, they gave me push pins, but they're all clear. That's fine. I'll use them. There's 12 there. I also took my 84-inch yarn, and I always look through my labs before I do any videos and stuff to kind of walk through them before I actually get into it, so I have an idea what I'm doing. I took my 84-inch yarn. I already cut it into my 7 segments of 12-inch pieces. You're going to need that so you can wrap it around the push pins to show your bonds. You're also going to need a ruler. That's just to measure the 12-inch pieces. And then you need scissors. Got the scissors right here to cut the yarn. And I got my camera to take pictures for my lab. It's just on my iPhone. And then a permanent marker. I used my black permanent marker here to actually write down the atoms that you're going to be dealing with on the corkboards. All right, so the procedure is pretty simple. It says you use a permanent marker to label the corkboard pieces with each of the following atoms. It tells you to label 2 cork boards with as chlorine. So you just take a cork board and you write the symbol down for chlorine. It wants you to do 1 for sodium, 3 of them for oxygen. So I got 3 cork boards ready for oxygen. 1 for magnesium, potassium, got my bromine, fluorine, and then there's 4 hydrogen. So I already labeled them. I already got step 1 done. And they give you a figure in the lab to show you how to do it. It's pretty simple. All right, it tells you to use step 2 to use the periodic table to determine how many valence electrons in each atom and record your information in table 1. All right. So before you record your information in table 1, I'm going to kind of step you through it because it's really not that hard to figure out the valence electrons, but I'm going to show you the long method, and then I'm going to show you kind of a more simpler way when you're dealing with the major groups on the periodic table. When I say major, that's groups 1, 2, so the first 2 groups here, so your alkali metals, alkaline earth metals, and then if you go through groups 3, 4, 5, 6, 7, and 8, those are your major groups on the edges here. All right, all the metals in the middle, those are not really, we're not going to mess with those too much. Okay, so in order to do it the long method, I made some cue cards here to make it easy, but we'll just start with the first one they tell us to write a cork board for, and that happened to be chlorine. And chlorine, if you just look at the periodic table, chlorine has an atomic number of 17 or 17. So if it has, that means it has 17 protons, so it's going to have 17 electrons. So if you write down the electron configuration, the longhand form, all right, that's the longhand form of the electron configuration, you're going to find that you're going to have 1s2, 2s2, 2 papa 6, 3s2, and 3 papa 5. So what that just, if you think about it, it's all the energy levels, and it goes in the order of the energy levels they should be in. And 1s2, there's 2 electrons in that level, in that sublevel. 2s2, there's 2 electrons there. In the 2 papa region, there's 6. And then you go to the next level, you have to put 2 and 3s, and then 3 papa, it'll only have 5, because if you add the top numbers of this, all these together, it'll be 2 plus 2 plus 6, which is 10, plus 2 is 12, and then plus 5 is 17. So that checks with me that, hey, I got my 17 electrons covered. And what you got to pay kind of close attention to is that your valence electrons are going to be in the outermost shell. You have to count all the electrons in that outermost shell. And sometimes I made this mistake the first time. I was just going, well, I'll just go with 3p5. So I thought 5. Well, that doesn't make much sense, because if you look at chlorine on the periodic table, it falls under group 7. And group 7 is important to understand. If it falls into group 7 or group 6 or whatever, group 7, that means it has 7 valence electrons. And you can prove that to yourself because you have to put in brackets, or you have to realize that you're dealing with the 3rd sublevel. So in the 3rd sublevel, chlorine has 7 total electrons, and it falls under group 7, so I know it has 7 valence electrons. So this is the longer method, or the harder way to get to the answer. The easier way to get to the answer is understanding your periodic table and how it works. There's also some good videos out there on this and how to use your periodic table to determine valence electrons, and I'll put a link to that one. And it was primarily by, a good one is Dr. Leslie A. She has a good method on how to use your periodic table to determine the expanded and then your noble gas or shorthand form of electronic configuration. All right, so back to what we were talking about here. All right, so I went ahead and made cue cards for everyone. Oh, did I lose my video? Give me a second there. Sorry. Okay, so again, this is what it's going to look like for chlorine. That's kind of what it's going to look like for sodium. So sodium's in group 1, so it's going to have 1 valence electron. Okay, and that happens to be in the 3s sublevel. And when you're looking at fluorine's in the group 7, so it's going to have, if you notice, I had to look at 2s and the 2 papa. There's 5 plus 2 is 7, so it's going to have 7 valence electrons. Bromine, this one gets a little tricky depending on how you write your longhand form. If you do it the long method, you got to, I was in level 4. Okay, so for the bromine, again, it's in group 7. 5 plus 2 is 7. All right, potassium is not too hard to figure out. You get to the 4s1 level, and you're going to have 1 valence electron. Magnesium, you're going to have 2 in its outermost shell. And oxygen has it has six valence electrons. Okay, so 6 valence electrons for oxygen. So that's, you don't have to make these cue cards, but what it did for me is it helped me practice, one, how to write the electron configuration long form, and then help me understand my periodic table during this lab. So it has you fill out table 1. I'm going to go ahead and fill out table 1, put it on pause, and come right back. All right, so I filled out my table 1 for lab 7, and again, it has you fill out the number of valence electrons. I'll just kind of go over what I got. And one thing to remember, I think will help out if you're having a hard time with this, is if you can't have more than 8 valence electrons for any atom on our periodic table here. And 8 is aligned with your noble gases. And again, all these atoms are trying to get to be a noble gas. So when they combine, whether it's covalent or ionic, they're trying to get to 8 in their the outermost shell so that they're more stable. Anyway, so for hydrogen, I got 1. Chlorine, I got 7. Sodium, I got 1. Oxygen, I got 6. Magnesium, I got 2. Potassium, I got 1. Bromine, I got 7. And fluorine, I got 7. And again, if you just go by the major groups and just go down the group, anything in this group is going to have 1 valence. Next one, you're going to have 2. And then over here in group 3, you're going to have 3. 4 is going to have 4 valence electrons, and so on in the outermost shell. Okay, so that's that. So table 1's filled out. All right. Now it tells me that I need to create hydrochloric acid using my cork boards. I'm going to obtain the chlorine cork board, and then I'm going to obtain one of my hydrogen. So I got a hydrogen and a chlorine cork board. It says use push pins to represent the valence electrons of each atom. So again, I've already determined what how many valence electrons hydrogen and chlorine have, and hydrogen, I think, has 1. So I'm going to put 1 push pin down for hydrogen. And chlorine is going to have 7 valence electrons. So 1, 2, 2, 3, 4, 5, 6, and 7. And because I understand how these kind of work, kind of show you, when I did put the push pins in, I kind of set myself up for success here. And to show you on each side, so when you're doing electron dot configuration with your push pins, and you can see there's 2 on the bottom of chlorine, there's 2 on the right hand side or left hand side there, and then the top's got 2, and then the side that it's chlorine is with hydrogen, it's got the 1 extra. So there's 7 for chlorine and the 1 for hydrogen. And if you notice, hydrogen again is trying to it's, I guess in this case, it's going to be willing to give up its electron to chlorine, and it's going to pass it over, or when it bonds with chlorine, it's going to share its electron or give its electron to chlorine. And I think in this case, you would end up having a slightly positive charge for hydrogen and a negative charge for chlorine. Okay. It says use my camera, take pictures of it, and represent. So I'll put it on pause and take a picture here.